So we're going to do 2.9 today at the very, very end of class. Probably not even until announcement starts is when I will hand back quizzes, because I don't want you to even think about them until we're done. Okay? All right? Tomorrow then in class, because it's a short class tomorrow, so tomorrow in class will be, we're going to go over, the first half of class, we're going to go over the quizzes, because there was a lot of like simple mistakes that people are still making mistakes on. So I want to go over the whole thing just to make sure that we figure out what we did wrong, and that way that will hopefully spur quicker corrections, if you will. Okay? And then we also have a worksheet then for the second half of class to work on in class. Okay? If you haven't taken that quiz yet, make sure you get that quiz taken before then so you can utilize that part of class tomorrow. Okay? With that being said, on page 36 in your white note packet, we have 4 find me y equals mx plus b problems, and 3 simplify it all the way down, get rid of the parentheses, make it look like y equals mx plus b without the y part. Okay? Right? Go for it. First 2 should have been pretty easy. If we want to put it in y equals mx plus b form, and they give us the m, and they give us the m, and they give us the b, and they give us the b, so then it would just be a plug in those 2 spots. Color-coded even. Y equals negative 3x plus 7. Y equals 2/3 x minus 18. Agree with those 2. Okay? Those were just straight plug and chucks. Okay? Then, as we were talking about, Emeril Lagasse kicked it up a notch. Okay? And said, now we want to go y equals mx plus b. But now here, it only gave us the m. Right? So we've got y equals 8x, because we can plug that part in. Y equals 8x. But this b part over here, that's the y-intercept, right? And what form does the y-intercept take? All y-intercepts have the same form. All y-intercepts have the same form. What do you got, Liz? So it's 0, comma, right? All y-intercepts have the form 0, comma, some number. Okay? Is this the y-intercept? No, it's not the x-intercept either, because the x-intercept would have some number, comma, 0. Okay? So this point doesn't do us any good directly to get to the answer to the equation. Okay? Not my school. Okay? Alright, so how can we use that point then?
Well, so the right over run is like 8 over 1, right?
Mm-hmm.
So couldn't you just subtract 2 off of the x and then do 8 plus 4?
That's one way. Yeah, you mentally do it in your mind. Okay, if we didn't have that mental capacity, though, what could we use? What am I going to plug into the equation? What am I going to plug in where? This is my x value, and that's my y value. And so I can utilize y equals mx plus b, because I know now that my y is 4, I know that my m is 8, I know that my x is -2, and I just don't know that b. But I can solve for it. Okay? 8 times -2 is -16. So this becomes 4 equals -16 plus b. And how would I go about solving that? For b. Add 16 to both sides. So then I get 20, oops, I forgot the equals, equals b. Which, Lily, if we would have done your way too, we would have had two jumps to get back to the 0, which means we would have had to add 2 8s, so 8 plus 8 plus 4 then, because we started at 4, would have gotten 20 also. Then, Emeril Lagasse again kicked it up another notch for number 4. Okay. Now, do I have the m? No. So how do I find m? Thinking back either to 8th grade or to last year, or knowing what you know because we've done it this year too, how do I find the slope between 2 points? How do I find the slope between 2 points?
It's like one of them is x1, x2, and then y1, y2.
Okay, what do I do with those?
You put them like on a fraction kind of, and then you minus like x minus y. I can't remember exactly.
X is on top or X is on the bottom?
I can't remember.
Need some help. What do you got? So subtract the y's over subtract the x's. Yep. Does the order matter?
Yes.
No.
No.
If you go this one minus this one, or the first minus second, you'll get the same answer if you went second minus first. Okay, so the order of that doesn't matter as long as you're made consistent with your x's and your y's. Okay? So m is going to be 8 minus -16 all over 2 minus 8. 8 minus -16. Eight minus -16. Nope. 8 minus -16.
24.
95% of you have a calculator in front of you. Okay? 8 minus -16, Piper is? 24. 2 minus 8. 2 minus 8. -6. 24 divided by -6. -4. So my slope is -4. Now we found the slope. Now it becomes a problem just like we did in number 3. Which point do we want to use? So you want to use 2, 8? Smaller numbers, no negative? Makes sense. That makes sense to use that one. Yep, okay. So this is going to be my x, and this is going to be my y. That's my m. So in y equals mx plus b, I've got 8 equaling -4 times 2 plus b. -4 times 2. -8. So then that gives me 8 equals -8 plus b. Add 8 to both sides. gives me 16 is B. That's a bad 16. So my equation then would be y equals negative 4x plus 16. Okay. In number 5, it asks you to rewrite the equations by combining like terms. So I'm going to factor in that negative 3, or I'm going to distribute in that negative 3, and I get negative 3x minus 15. Then this minus 2 stays along for the ride, so this one would be negative 3x minus 17. Here on this one, I would distribute in the 7. Gives me positive 7x minus 22. And then here I would distribute in the negative 8. That would give me negative 8x plus 8, still with a minus 11. So that would be negative 8x minus 3.
How did you get 17 for that one?
Negative 15 minus 2 is negative 17. Okay. Which, these all look like the explicit linear equations that you guys have been making now for like 7 weeks. Okay? That's what those all look like. And we're moving towards, this looks like y equals mx plus b now. Okay? So that's what they're moving toward. They're moving us towards everything's in y equals mx plus b. You can still start with that equation, but now we got to simplify it down to y equals mx plus b. Okay? Awesome sauce. So, let's talk about Kwan's parents' house. Okay? And I already know there's not a lot of workspace here, but we'll still figure it out. Okay? So Kwan's parents bought a home for $50,000 in 2007. Just as the real estate values in the area started to rise quickly. Each year, their house was worth more and more and more until they sold their home in 2017 for $309,587. Okay? It is asking us to model the growth of the home's value from 2007 to 2017 with both linear and an exponential equation. Then it says graph it, but I'll graph it for you. You guys don't have to worry about the graphing part. So if you want to do your work here in the graph, that's fine. Okay? So our linear model is going to look like y equals mx plus b. Or we could have also said here f of x. Okay? Y and f of x are interchangeable. Okay? Our exponential model is going to look like y equals a times b to the x power. Or, once again, f of x equals a times b to the x power. Okay? Would it help for us to make a chart? Yeah? Okay, let's make a chart. What are my titles going to be of my, well, first off, let me ask, you want a horizontal chart or you want a vertical chart? Horizontal? Okay, right? What's going to be my title of the top line? Years. Yep. What year it is. Okay. What's going to be the title of my bottom line? Value. Okay. What's my first data point going to be? What do you want? 0? 0 and 1? Because I need a data point, so I need both. You know what I mean? You understand what I'm saying? Like you can't just throw out one number when I need two. What do you got? 0 and 50,000. So 0 for the year, 50,000 for the value. Okay, and we got that from there. Okay. What's my second data point going to be? Now again, knowing that 2007 now has just become year 0. What would my second data point be? Okay. Oh, no, it's the only two we got. They can be right next to each other. Okay? We need to make a linear graph or a linear equation out of that. So what do I need in order for me to make y equals mx plus b? I need the slope. How am I going to find the slope given 2 points now in a table? So it's changing y's over changing x's. Which one is y's, which one is x's in this scenario? So the years is the y. Value is the y. So the years would be the x. Okay. Find me the slope. Agree with me that the slope is 25,958.7. Okay. So my equation is going to start f of x is going to equal 25,958.7 x. Now I need my y-intercept. What is my y-intercept? Why is it 50,000? Because that's where x is 0. Yep, exactly. So this just also happens to be the y-intercept because it's where x is equal to 0. So that means then here at the end of this, I need plus 50,000. we got to figure out how to come up with the exponential model. Okay? My A value here is going to be 50,000. My exponent is going to be x, because that's going to be x minus 0. We just need to find that B value. Can somebody refresh my memory as to how I find the B value in an exponential equation? Nope, that's linear. Now we're in exponential. We called it R, just so you know. We called it R up until this point. Okay? Just that? Do we agree with that? We've actually done it today. We did it when we were going over the homework. How do I find the R value? In this case, it's B, but B and R are the same thing. It's geometric, yep, because it's exponential. Lily, I will let you know, you were on the right track. You just forgot one crucial thing. The radical, right? We put that all under a radical, okay? And we put the 10th root on top of it, because it would be 10 jumps to get over there. From 0 to 10 is 10 jumps. Yeah? Okay? So calculate that for me on a calculator, please. 10th root of that number. You know you did it. Or do you need me to teach you how to do it on yours? Oh, okay. Why are you yelling at me? Okay. So that means that we're going up by 20% then, every year? Yep. Okay. Now, there's a bunch of questions that we're going to talk about here after this. We're going to skip a few of them, but I do want to talk about at least the first one, or the three that are right underneath this, this stuff. Okay? So the first one is, what was the change in the home's value from 2007 to 2017? What was the change in the value of the home? But how much did it go up? Andrew?
25,958.7.
No. It went up this number. This number up here is what it went up.
Oh, I read the wrong.
Yep, you gave me the average. You gave me the average that it went up every single year. Yep, this was asking, and that helps to, because one of the things that, and trust me, I'm the same way. One of the things that we struggle with is we struggle with reading the problem because we just want to get it done. Okay? Because the quicker it's done, the quicker we're done with it, and we can go on to something else. Okay? I get it. Okay? Totally get it. Okay? But we got to read it. So this one said we wanted what was the change in the home's value from that time frame. So that this answer here is going to be $259,587. Okay? The next question says, what was the average rate of change? So that's how much it changed. It changed in 10 years that much. Okay? So the average rate of change here would be $25,958.70 per year. Okay? Wake Fabian up. Fabian's falling asleep in the back. Fabian's going to learn that he's going to have a new seat right up here very soon. Okay? Okay? So that was the average rate of change for the linear one. Now, what is the average rate of change for the exponential one? What? No? 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 I need a number. I need like a dollar, average rate of change. How much it changes per year? No? Would it help if you saw the graph? Okay, let's see. I'll show you the graph. Here's the graph. The red line is the linear function that we came up with. The blue curve is the exponential that we came up with. So what is the average rate of change on the red line was $25,958.7 per year. What's the average rate of change for the blue curve? In dollars. You have all the information. You have the same information on your paper. Truly, you didn't need to see the graph in order to answer this question. Ready for it? Why is it a trick question? Why?
Because, like, the average is just, like, take all of the numbers and divide them. I don't know why it's funny.
No matter which function we go on, we're still going through that blue and that pink points. Those values. Right? At the same time. So no matter what happens, that average rate of change is that slope between those 2 points. Okay? Now, if we would turn the page, now it says, let's adjust it to 2012. Okay? Well, the problem with 2012, and here's where I can actually show you this on the graph. The problem with 2012 is 12, so that would be 12, this would be here. Oh, no, that's 5. Why is that 5? Wait, no, yeah, this. 2012 would be 5. Yes. Okay? So 2012 doesn't go through the exact same spot. So those rates of changes would be different. Okay? Because they're going through 2 different values depending on which way you're looking at the value of the home. Okay? There it goes. Okay? So depending on how you're looking at it, it goes through two different values. So those rates of change would be different. The rate of change for the linear one would obviously be bigger because it's growing faster in that part. After 2017, the rate of change for the exponential would be bigger. Okay? So the average rate of change can really just be summed up as the slope between two points. Okay. What this is saying here is this is saying the value of the function when you plug b in. Okay? So that would be the second point. And then this would be the value of the function when you plug a in. And then it's an average because then you divide it by b minus a. You get the average by doing it that way. Okay? Last thing I want to talk about here is I want to talk about what this slide truly means that you see every single day. Because when I was walking around earlier, and it was even worse in the last class, what does this slide truly mean? We got it. Not necessarily at home. I mean, yes, ideally, okay, but you may have some other time that you could do it at. Yes, ma'am.
What you're supposed to do out of class. Like,
Okay, so it's definitely, because not all the time do we get time to work in class. Okay, yep. When should it be done?
by the time the next day.
The next day, the next class. Okay, we are struggling with doing homework for the next class. Okay, some of you in this room haven't done homework yet this year. Okay, I'm going to pause to let that sink in. Some of you haven't done one homework. We have a test in a week. If you are not caught up, that's on you. Okay? You need to find the time to do this. When we put this slide up, that's part of being a young adult. Okay? Part of being in high school. This is due. Okay? Right now, we're pretty liberal with our, we don't need to necessarily, and I'm pretty liberal with, I don't really take off points for you being late with your work. Okay? I say the test day, so next week, Thursday, is when all 11 homeworks are due from Unit 2. Why are we shuffling papers? I say next week, Thursday, is when all of the homeworks are due for Unit 2. I can easily go back and say they're due the next day. It's not that hard for me to say that. And then start taking off late points for them. Okay? I don't want to do that. That's not how I roll. Okay? Don't force me to do that. Okay? Get your homework done. Get it done. Okay? So, you do have 16 problems to do tonight. Let's take a quick little peek at them. Couple of rewrites on those. Okay? All right? And then you'll notice something about them in number 2. Couple of rewrites in number 4. That's kind of what we were doing in that retrieval when we started today. You'll notice something about them. Okay, so that's good. So that's 6. Finding out, one's a linear model, one's an exponential model. Finding out the common differences, common ratios. Compare the change between each one. Tell me what you observe. Ooh, lots of writing. This, in number 10, it can truly be a rough sketch. But, on this one, make sure that you label your axes. How do we label axes? Half expected nobody to answer that question because it's been a problem. What do you got, Andrew?
Either with the labels they give us or with X or Y.
Okay. All right. So in this case, we would probably have some labels that we could do. Okay. So how, in what fashion, in what form do those labels come in? Like words?
Yeah.
Okay, so we need to label it in words for one, and units. We got to have numbers on there too. Okay, so when I say label your axes, I want a description of what that is, and it can be one word: money, value, something like that. Okay, and numbers, or it could be time, and then you could say minutes or something like that. Okay. Right? So when we say label our axes, we've got to do a better job of labeling our axes. Okay? Observations. Ooh, finding slope then. We got finding some slopes and some goes. Ooh, yeah, like that. Ooh, yeah, we're definitely going to want a calculator with those for some of those numbers. Yeah, good times. Okay? Any questions initially, first view of the homework? Fantastic. I'm going to hand back your formatives right now, and then we'll be done.